Okay, it's time to get started. Thank you everyone for joining our live lecture today. My name is Isaac and I'll be the lead instructor for the lecture. And today's topic is going to be database foundations in NoSQL. Okay, so let's go ahead and let's start by discussing what is a NoSQL database. And simply put, a NoSQL database is a database that allows the insertion of data without a predefined schema. Okay, so if you're familiar with traditional databases, you must tell the database what kind of format the data is going to come in before you insert it. But now with MongoDB as a more modern feel, and you actually don't have to give it a structure, it'll just accept data. So that being said, let's go ahead and discuss what type of NoSQL database we're going to be using today. And the type of database we're going to be using is a MongoDB database. Okay, so just know that there are more than one type of NoSQL database, but MongoDB is probably the biggest and most proven so far. Okay, so you'll need to download that on your machine because that's going to come with what's called the Mongo shell. And the Mongo shell is a utility that's going to allow us to communicate with our database and perform operations such as inserting data or retrieving something to that nature. Okay, so as well as learning about MongoDB, we're also going to be learning about MLab. Okay, and MLab is a cloud provider for MongoDB. Okay, so it's a MongoDB database, but it's in the cloud instead of on our local machine. Okay, so first thing I'm going to do is under MongoDB deployments, I'm going to create a new one. And then from here, we can go ahead and we can select, which looks like the create wizard's having an issue. So let me just refresh that. There we go. Okay, so I'll select AWS for the cloud provider and Sandbox for the free version, and we'll continue. And then next, we need to select the region nearest us, which for me, it's the first one. Okay, next, we'll go ahead and give it a database name. Let's say this is the greatest DB ever. Okay, and we will verify everything's correct and submit that. Okay. So it looks like that went through smoothly. Okay, so now we can go ahead and click on that database, and let's go ahead and discuss, the anatomy of what's going on in here. Okay, so a MongoDB database is made up of what's called collections. Okay, and collections are like categories of data. So Facebook, for example, has like users collections and posts collections, right? Those are two separate categories of data. And so you would put those into separate collections, but they would be in the same database, okay? And then within each collection, you've got individual records, which are referred to as documents, okay? And these documents are represented in like JSON format, so you got key value pairs, and that's how we, access the data. So that's, the basic anatomy. The authentication part of the database comes under the users tabs here. And, by default, we have an account user, but then we can also add database users. For example, this would be like the company, and then the database users would be, the individual developers or managers that had access to the database. Okay, so I'm going to go ahead and I'm going to add myself as a database user, and I'll just do an easy password like 123. Okay, so now I've added a database user. I can authenticate this database using this connection string right here. Okay, so see how it says to connect using Mongo shell. So I'm just going to copy the connection string. And then from here, we're going to navigate to our command line. And in our command line, let's go ahead and paste in that connection string. And then let's change out the placeholders for database user and also for the database password. Okay, and now it's going to let me authenticate, and now I'm connected with that cloud database from my local machine. Okay, so we have a connection, and from here I can perform various different operations in my database. Okay, so the 4 core operations you're going to be performing are referred to as CRUD. Okay, and CRUD stands for create, read, update, and delete. So knowing that, let's start with creating some data and inserting it, okay? So right here in our collections, let's just go ahead and let's say we want to add, car data. So we'll have a cars collection. Okay, and as you can see, we have 0 documents right now. So let's head back to our utility here, and let's use this to insert data into our database. Okay, so I'm just going to start off by saying db dot collection, and in this case, the collection name is cars, and then we use the command insert one. From here, we just pass in an object. So, brackets, the key value pairs. I'll just say, the type of car is equal to Tesla. Okay, and let's do the year of the car equal to 2017. Okay, so as you can see, it acknowledges successful and generated this ID for this document. So if we go to the MLab and we refresh, you can see that in our cars collection, we have one document. The document, is a Tesla, the year 2017, and here's this unique identifier. Okay, and this is automatically taken care of for us by MongoDB because it needs some way to differentiate the items in your collections. For example, if 2 cars have the same type of Tesla, right, and the same year, it's going to be really hard to differentiate those. So this is where a unique ID for each document comes into play. Okay, so let's go ahead and practice that a bit more. Let's insert a couple more cars. So we'll say db.car.insert another one. Let's say the type for this one will be Mercedes. And let's say the year is going to be 2006. Okay. Then let's go ahead and let's execute that. And then let's go ahead. Let's say db.cars.insert one type, and we'll say BMW. Let's give it a year of 2000. Okay, so now let's go ahead and head over to our database. If we refresh here, we can see that we have 3 different cars in our collection, right? They each have a unique ID, type, and year. Okay, so that's how we can create data. So now let's go ahead and let's discuss how we can read the data. Okay, and reading data from a database is generally referred to as a query. When you run a query, you're requesting data in a certain format. Okay, so it can come in a lot of different shapes and sizes. You can request all the data from a collection. You can request certain specific documents from a collection, right? There's a lot of different variations of these queries. So let's just go ahead and start with a general request for all the collection or all the data in a given collection, okay? So how I'm going to do this, I'm going to say db.cars.find, okay? And then I'm just going to pass in an empty filter here, and that's just going to return all the cars in this collection, all the documents in this collection, okay? And as we can see here, we get 3 cars, right? So that's a general request, but sometimes we're not going to want all the cars, right? Sometimes we're going to want to find cars by like a quality. So let's go ahead and explore that. So to find a car by, say, their given type, we could use the following approach. We could say db.cars.find, okay, and then we'll go ahead and we will say type, and we'll use the equal to operator, and we'll pass in Tesla. Okay, and as you can see, when we execute that query, we only get 1 car returned. Okay, and that's the car with the type of Tesla. Okay, so as you can see, between these 2, we're requesting different information now from our database. Okay, so let's go ahead and continue, and let's talk about how we can how do you say it? How we can run a query based on a comparison operator. Okay, so greater than, equal to, that kind of thing. So let's go ahead and let's try to find all cars with the year greater than 2005. Okay, so we'll say db.cars.find, and then we'll say year is greater than 2005. Okay, and as we can see this time, it only returns 2 documents, right? That's because they both have a year that's greater than 2005. However, our BMW did not, so that was not returned. Okay? So next, let's go ahead and let's do the opposite. Let's find all cars less than 2005. Okay? So how we're going to do this is we will say less than 2005. Oops. Looks like I missed something there. Let's try that again. db.cars.find. Year. Oops. It keeps hitting enter. Let's try that one more time. db.cars.find. Year is less than 2005. Okay, excellent. So as we can see, it's only returning one document, right? And that's the document whose year is less than 2005. Okay, so let's go ahead and let's continue by talking about logical operators. So logical operator, unlike a comparison operator, allows us to combine queries into more compound searches. So for example, let's say we want to find all cars greater than 2005 but less than 2010. So how we could do this using an AND operator is we could say db.cars.find, okay, and then we will say and parentheses, or not square bracket, and then from here it's just a matter of passing in our queries. So we'll say year is greater than 2005 and year is less than 2010. We'll close the array here. And we can see we only get one car returned from that query, and that is the car with the year 2006, because it is between 2010 and between 2005, right? And it's the only car that matches this truthful query. So moving right along, let's go ahead and let's also explore how we can set up projections with our queries. Okay, so oftentimes the data in our database, these documents are going to be quite hefty in size, lots of data, and for performance reasons, we don't want to just request everything from a document if we only need like one piece of information from that document. Okay, so what we can do is we can set projections to only query what we want from documents and increase our overall performance. So let's go ahead and let's explore what this looks like. So I would let's say we only want to return the type of car. We don't care about the year. So how I could do this, I could say db.cars.find, and then I will say year is 1 for true. If I pass in 0, that would be false. Okay, so let's go ahead and find all. And oh, I did year instead of type. So let's go ahead and try that again, but I'm just going to use type instead of year. Okay, but as we can see, it returns all the documents, right? But there's no year here, right? There's only the type returned. By default, it's going to return this ID to us because we're more than likely going to use it. However, if we want to leave that ID out of things, we could simply run a projection like this. We could say type equals 1, and then underscore ID equals 0. And if you remember, 0 equals false, and therefore it will leave that out of the query. Okay, so as we can see now, we're only getting the type of all of our documents because that's the only information we need. All right, so once again, that is referred to as a projection. So moving right along, let's go ahead And let's finish up talking about the other half of our CRUD operations, right? We've seen how we can create data and how we can read it in many different ways. So let's go ahead and see how we can update data and delete it. So let's say we want to update our Tesla, which is in our database with the year 2017, and we want to update that to the year 2018. So how we could accomplish this is the following approach. Okay, so we're going to say db.cars.update1. Okay, and we're going to be updating car with a type equal to Tesla. Okay, and then we're going to use the set operator, set the value of the year to 2018. Okay. So year, there we go, 2018. Okay, close that up. Or actually, we got to upsert real quick. So let's go ahead and do that. We will say upsert true. That just means, replace the entire document. Okay. So now let's go ahead and let's just close that off. And oops, yeah, looks like it. There we go. That's better. Put that E back. And I think we're good. Let's see here. No, we need just one more. Yeah, maybe that's good. That was quick. All right, so we basically targeted the type Tesla and set the year to 2018. Replaced the whole document, and it came back as successful. So if we go to our database now and we refresh, we can see that it's 2018 instead of 2017. Okay, so we've successfully created an update operation. So now let's go ahead and let's delete a item in our database. And so just a word on this. Normally, it's a very bad practice to ever delete anything in your database, but just for the sake of seeing how it works, we'll go ahead and go over that. So keeping that in mind, let's say we want to delete a car with a type of BMW. So how we could do this is we could simply say db.cars.delete1. We'll delete a car with a type equal to BMW. Okay, as you can see, it came back as successful. So if we go to our browser and we refresh, you can see that we only have two documents now, right? The Tesla and the Mercedes. And yeah, it's because we just ran that delete request. Okay, so by now we have successfully completed all the CRUD operations, right? We created data, we've read it, we've updated it, and we've deleted it. Okay? So next, let's go ahead and let's talk about indexes. Okay, so to make your application more performant, you should set up indexes for fields that you query often. For example, if we were always querying a car by its type, if a type was a search that was used a lot, it'd be good to create an index. And an index is just an ordered copy of that, which allows our database to more easily look up that information. Okay, so if we go back to MLab and we look under our indexes tab, we see we already have one set up by default here for _ID, because that's something that is commonly referenced in a database search. However, we can definitely add more. So let's go ahead and let's add an index for type, okay? So how we're gonna do this, we'll say db.cars.create index, okay? And then what we can do from here is we can go ahead and pass in the particular fields we want, right? So I'll say type 1, okay? And that's equal to true, okay? So as you can see, it gave us a success message. So if we head back and refresh our, MLab here, we can see that we not only have ID, but we also have type now, as an index, right? So we're going to be more easily be able to look that up, okay? So remember, rule of thumb, just set up indexes for fields you query often on documents. Alrighty, so moving right along, let's wrap up with the topic of one-to-many relationships. Okay, so one-to-many relationships are all over the internet. You see them all the time. You just probably aren't aware of it. Okay, so I think one of the best explanations for one-to-many relationship is Yelp.com. So let's go ahead and navigate there. So we'll go ahead and say Yelp.com, and how a one-to-many relationship is working here is Yelp is associating one category with many places, okay? And so let's go ahead and just test this out. We'll say food near San Francisco, right? And now, we got all these places associated with just this one food category. So let's go ahead and let's set up, a similar structure in our database to where we have categories collection, and we also have our places collection, and we're able to perform and run one query to get all the related data for that particular category. So I'm going to start off by going to my database. I'm going to create a couple new collections. So the first collection I'm going to create is my places collection. Okay, and then I need to have a category to relate to a group of places. Oh, actually, I should have called that categories. So let's just go ahead and put that back, right? Okay, so we got categories and places. Okay, so I'm going to start with places. Okay, let's create some places, insert them to our database. So let's just start by saying db.places.insert1. Okay, and let's just have the name of the place equal to Disneyland. And let's see here. Let's also have the category of the place equal to entertainment. Okay. So from here, we can go ahead and insert that. And then let's go ahead and do the same thing for a couple other places. We'll say insert one, name equals, let's say Universal Studios. And then the category, let's make it the same as Disneyland. It will be entertainment. Oops, I forgot to wrap that up there. Let's try that again. db.places.insert one. And then we'll go ahead and pass in name, which will be Universal Studios, with a category equal to entertainment. Okay, so we'll just close up this operation, and that's another one in back. Okay, so now we've got a couple entertainment places. Let's create a different category. Okay, so I'll say db.places.insert one. Okay, and then we'll go ahead and insert a food place. Okay, maybe we'll say Burger King. Okay, and the category will be food. Okay, so if we head back to our database now and we refresh, we could see that we have 3 different places, right, which all have a name and then the category which they are related to. Okay, so now I've created small one-to-many relationship here because I can just query all the places with category of entertainment, and it'll just return all those accordingly. Okay, so next, let's go ahead and let's set up our categories. Yeah, right in here. Let's set up those documents. Okay, so I'm going to say db.categories.insert1. Okay, and then let's go ahead and insert a name for a category. So I'll just start with entertainment. Okay, and then let's go ahead and let's add an array, which will be used to store the IDs of the particular documents in our places. Okay, so because Disneyland is entertainment, I'm going to take this ID, I'm going to add it to the array. Oops, let's just do that as a string. Okay, and then we can go ahead and now we've got our first ID passed in. We'll just take the second ID here because it's also entertainment, and we'll pass that in as well. Okay, and then we can go ahead and we can add a place for this. Okay, so we can come back here and I'll just say places colon, and then the value of places will be this array here. Okay, this array of values. Okay. All right. So that went through successfully. So if we go back to our database here in categories, we can see that we could just request with one single query the entertainment document, right, with match the name of entertainment, and it will have all the associated places, right, which we could just loop through and display for the user or whatever else we want to do. Okay, so let's go ahead and let's add the food category. Okay, so I'm just going to say db.categories.insert1. Name will be equal to food, and the places associated with it is just the one food place. Okay, as we can see down here, we've got Burger King, right? So let's go ahead and let's take Burger King, or the ID for Burger King, and let's pass that in our array here. And that's the only one we have, so we'll just close that off and execute. Came back successful. So from here, we can go back to our database. You can see we have 2 category documents, okay? And one is entertainment, and one is food. And they both have, the one-to-many relationship set up between them. Okay, so let's run a similar query like we ran on Yelp. Okay, so now all I have to do is I just need to say db.cars.find, and I'm going to find, not the cars, sorry, db.places.find. Okay, let's say I'm hungry, so I want to find all places associated with food. Okay, so I will say name food. Okay, and oh, that's right, we put it under category. So let's say db.places.find all the places with a category equal to food. Okay, there we go. So it only returns one document, and that is Burger King. Okay, so we go there, we eat some food, and then we're ready to have some fun. So let's find all the places that have an entertainment category. Okay, so I'll say find then I will say category equal to entertainment. Okay. And as you can see, it only returns 2 documents now, right? The ones associated with entertainment. So we've successfully set up a one-to-many relationship. So let's go ahead and open up the floor, and let's see if anyone has any questions on what we went over. Okay, so the floor is open. Your mics are unmuted. Feel free to ask questions if you got them. Okay, nothing, no questions today? All righty. Well, thanks everyone for coming. Have a great day and happy coding.